9.5 practice problems. The synthesis of ammonia is represented by the equation above. Based off of the equilibrium constant K and delta H for the reaction above, which of the following can best be used to justify that the reaction is thermodynamically favorable at 298 Kelvin with a constant pressure? So we can see that the K is very, very large. This means that our equilibrium constant is very large, and so we are going to be going nearly to completion. And then our delta H is also negative. So since our delta H is negative, and my K is so large, that does mean that we should expect that our delta G is going to also be negative, indicating that it is thermodynamically favorable. And so that option choice is going to be between B and C. And then we just need to differentiate here. So we don't have the values for our enthalpy. Instead, we have K. So we need to be utilizing this equation here. The delta G is equal to negative RT ln K, or the natural log of K. And our justification would be B, because K is very, very large. That would make my delta G very large. This equation here is going to very much give me a very large negative number. The sample of phosphorus oxychloride is placed in a closed rigid container at 298 Kelvin and allowed to reach equilibrium according to the equation above. Based off of the value for delta G of positive 298 kilojoules per mole, which of the following is true? So since we have a positive delta G, that does mean that we should be looking at a small k. So our equation that we're going to be originating from is that delta G is going to be equal to the negative RT natural log of k. And so if I want this net to be positive, then I need this negative to cancel out, which means that my k should also be negative. So I'm going to eliminate any answer choice that says that the k is going to be positive, and then I'm going to go ahead and look here. My delta G is very large and positive, and so I can go ahead and rearrange the equation here. My K is in doesn't have any units. However, R does have units of joules per mole, and so that means that I would need to convert out of kilojoules for my delta G. This is kilojoules, so I would need to go ahead and add 3 zeros. So then I can just go ahead and check these two equations here, where my delta G value needs to be the 490,000, not 490. Again, this is inappropriate because this is still in kilojoules, but my R value is in joules, so that does not cancel. So that means that option A is going to be my only answer choice because this is inappropriate units. Based off of the chemical equation and the delta G given above, which of the following justifies the claim that the HA, aqueous, is a weak acid? So we have that our delta G is going to be positive, and so that means that this is not thermodynamically favorable. We're not doing a great job pushing to completion. We don't really want that to happen, and so with the equation that delta G is going to be equal to negative RT natural log of K, if I want my delta G to be positive, then that means that the K needs to be negative, and so I can go ahead and get rid of any of the answer choices that say that K is going to be positive. Okay, And then I am basically just comparing these here. So we have partial dissociation versus does not dissociate. So does not dissociate would mean that my equilibrium constant there is going to be 0. I don't have any dissociation, and so that would completely get rid of that. So that means option choice C is my best and only answer choice for that question. On the basis of the information above, the dissolution of iron 2 fluoride in an acidic solution is, and we're going to go ahead and look at our K values here. So we have a very small but positive K value, a relatively large K value here that is also positive, and then we are looking for our K3 here. And we're looking at overall thermodynamic favorability there. So when I am looking at these two net equations there, I can go ahead and collapse them down. And so we see that we are going to need 2 of this. And again, I am still overall positive. So I can eliminate any answer choices that say that that K is going to be negative or less than 1 at least. And I am going to be able to collapse these down and combine. And so it is going to be thermodynamically favorable specifically because of the net equation being greater than 1 being positive. So option choice B is my best answer choice. At 25 degrees Celsius, the equilibrium constant for the reaction represented above has a value of 1.3. At 50 degrees Celsius, the value of equilibrium constant is less than 1.3. Based off of the information, which of the following must be correct? Okay, so we have a greater equilibrium constant at 25 than at 50, so we are more favorable at 25 degrees than at 50. Okay, so looking at all of these answer choices, answer choice A says that the reaction rate decreases as temperature is increased. Just because the equilibrium constant changes doesn't mean that the overall reaction rate is going to change, so that is not going to be a great answer choice. Option B says the reaction is thermodynamically favorable only at temperatures above 25 degrees Celsius. So we went from a higher equilibrium constant to a lower equilibrium constant, indicating that we are actually dealing with an exothermic reaction. And so we do have favorability at 25 degrees and a slightly lower equilibrium constant at 50. So B does not make any sense. C says that delta G is going to be positive. We know that our K value at 25 degrees. So we know that our K value is 1.3, and again, delta G is going to be equal to the negative RT, the natural log of K. Our K is positive, which means that this entire thing is going to net negative, so that is not our answer choice. We don't have any information really about our delta S. We are maintaining aqueous status between all of these, and this is again not really enough information. So while we can look at this and see while we're decreasing the overall number of molecules here, which would indicate a negative delta S, we don't have a whole heck of a lot of information. So again, not a great answer choice. And then E is going to, we're going to look at our delta H. This is going to be for whether we are exothermic or endothermic. And so since K is going to decrease as I increase temperature, this does represent an exothermic reaction, which means that energy is going to be releasing as we are going through the reaction choice. And then for exothermic reactions, delta H is going to be negative. So my best answer choice is option E.